So today we're looking at law of cosines. Law of cosines, we've solved using law of sines before. With law of cosines, we have an oblique triangle. If we can't use SOHCAHTOA because it's not oblique, then we can use law of sines or law of cosines. On our triangle, you can have any sides you want. I can have any angles I want. I'm going to call this x and this lowercase x. These must be opposites. The angle and the side that's named after it have to be opposites or opposite of each other in the triangle. So with that said, I'm going to first write a formula. You don't have to write this formula down. That should look familiar. What is that? Pythagorean's theorem, which works for what type of triangle? For right triangles. Well, they figured out that if it wasn't right triangle, that they could actually do this and it would work. And then they actually give you three formulas in the book where if this is the hypotenuse, this is the biggest angle. If this is the shortest side, if this were A instead, this would be the smallest angle. And if this were the middle-sized side, then that would be the medium-sized angle. I don't memorize the three separate rules. I just memorize one and then swap the values around. But I have a lot of people who like to do it this way. X squared equals a squared plus b squared. A squared and b squared can be any sides, even the hypotenuse, minus 2ab times cosine of angle x. And the key part here is that this angle and this side have to be opposites when you set up your equation. If you don't have it set up that way, then it will not work. I'm going to draw a picture for letter A, where I have angle C, that's 65 degrees. I don't know side C. That's why we're going to want to use law of cosines. I don't know angle A, but I know side A is 5. I don't know angle B, but I know side B is 8. We can't use law of sines for this problem because I don't have an angle for these two to say sine of the angle over its opposite side equals sine of 65 over this side. Law of sines won't work. I'll have too many variables. In fact, if you look, I have two sides, and the angle that connects them, that's side angle side. So if I have two sides and the angle that connects them, side angle side, then I have to use law of cosines. So I'm going to write this formula. I know the angle is 65 degrees. Trying to find C, so that's what's going to go here. Whenever you're doing this, one of these is known and one of these is a variable. Right now, I know the angle. I'm trying to find the side. I don't care which one goes first, A or B, it doesn't really matter, as long as I know they're not the one that's by themselves. Oh, and the cosine of, or C is 65 degrees. Cosine of 65 degrees. All right, so we've set this up. According to order of operations, we have to do parentheses, which I just have numbers in there, nothing to no operations. Exponents, so I need to square these first. Multiplication, there are 1, 2, 3, 4 factors over here. Cosine of 65 is one of them. And then addition and subtraction. But I have good news. We don't have to really think too much about that because there's all numbers over here. The variable is already by itself over here. We just have to undo the squared. So we're going to put all this in the scientific calculator at once, or graphing calculator, because they can do order of operations for us, which is helpful. So 5 squared plus 8 squared minus 2 times 5 times 8 times cosine of 65. Oops. Close parentheses. And I get this number. That's what C squared equals. So I'm going to do the square root or raise it to the 1/2 power to get the square root. So that's 7.4 to the nearest tenth, because they say up here round side lengths to the nearest tenth. So C is roughly 7.4. All right, now that I know the side length for letter C, I could use law of sines to get an approximate if I want, but I'm actually going to show you, actually this is my biggest angle, so I'm going to show you how to find the angle using law of cosines. So now I have three sides. I'm trying to find this angle. It's opposite of this side. So I'm going to rewrite this formula, but this time with angle B here and side B here. So I have my 8 squared. My other numbers are 7.4 and 5. So 7.4 squared plus 5 squared minus 2 times 7.4 times 5 times cosine of angle B. Order of operations, all of this stuff is multiplied together, so I can't, it's all connected. It's like this times x or times b. I can't do anything with these numbers other than to multiply these three together. I can square this one, and I can square these two and add them up, just like I do with Pythagorean's theorem. So I have 64 equals 7.4 squared plus 5 squared, which is 79.76. My 2 times 7.4 times 5 is 74. Now the biggest mistake people make is they subtract these numbers. This is like 79.76 minus 74x. The 74 is connected through multiplication, so you cannot subtract these. Order of operations won't let you. So what do I have to do to solve for b? What am I going to have to do first? Subtract the 79.76 first. Gets me negative 15.76. Now I'm going to divide by negative 74, which is going to make that positive. 15.76 over 74, because negative divided by negative is positive, equals cosine of b. How do I undo cosine to get angle b? Cosine inverse. So I'm going to do cosine inverse of 15.76 divided by 74. I get 77.7, they said round to the nearest degree, so 78 degrees. Now if I want to be really, really accurate, I will solve for angle A the same way. Putting a 5 here, and the 7.4 and the 8 here, 7.4 and 8, and going through this whole process again. If I'm not concerned about being as accurate, I could simply say sine of A over 5 equals sine of 65 over 74, or 7.4. Okay, I can use law of sines. I gotta make sure I find my biggest angle first though before I start using law of sines. This is my biggest angle, the 78 degrees. So I have the 65, the 78. We kind of know what we think the other one's going to be. I'm going to multiply by 5 to clear this denominator. So 5 times this divided by 7.4. And then I'm going to do sine inverse. So I'm going to do sine inverse of 5 times sine of 65 divided by 7.4. And it gets me 37 or 38 degrees, 37.7, 38 degrees. I just checked that those add to be really, really close to 180. I actually get 181. And so I would probably look at which one I rounded up that was not as close to rounding up. I think it was this one, but we're going to go with this one. We'll make this just 37. And we're good. It's approximate. If I use law of cosines, it should be exact. Law of sines is good, but law of cosines would be a little more exact on that. And what happens is I rounded this to 7.4, and so because I don't have all the decimal value, it's going to be off by just a little bit. So if you get close to 180, you're good. If it's not close to 180 and it's a lot off, well then we have a problem. going to ask you to set up letter C to find the first side, and then I'll show you letter B. Try letter C to find the first side. All right, if you set it up correctly, this is what you have, because angle A and the 34 degrees are opposite of each other in the picture. They are also opposite of each other in the equation. I'm going to do all of this in the calculator at once, giving us 32.93. But we have to do the square root to find the value of A. So A is roughly 5.7. Any questions on solving for A using law of cosines? So my picture, I'm going to do 5.7, and I'm going to get a little bit lazy here and find the next angle. I'm actually going to do two things. I'm just going to use law of sines. Because I have this angle and this opposite side, I could use law of sines to find the other things. So I'll have sine of C over 10, because those are opposites, equals sine of 34 degrees over 5.7. And then sine of B over 7 equals sine of 34 degrees over 5.7. Now we're going to cross multiply and solve. So I'm actually going to multiply by 10 to clear this denominator. I'm actually going to do sine inverse of this whole expression to find the value of C. So sine inverse of 10 times sine of 34 divided by 5.7 gives me 78.82, or 79 degrees for angle C. I'm going to repeat this process for angle B. Solving for angle B, I'm going to multiply by 7. So I'll have B equals the sine inverse of 7 times sine of 34 degrees divided by 5.7. And I get 43.37, or 43 degrees. And do I leave my answers exactly like that? Some of you are noticing that there's a problem. 43 plus 79 plus 34 is 156. Is that off by just a little bit?
No.
No, it's off by a lot. Not just a little, but by a lot. Now we haven't gotten to this lesson yet, and so it's a little frustrating. It's actually coming after the first part of the BA. Right now, you guys were told, hey, on our unit circle, if I want to know where sine is 1/2, well, it's here and somewhere else, right, on the circle? So you have all these values on your unit circle. So based on quadrants and what quadrant I tell you, you have to find sine inverse based on that. But because from here to here it goes up from 0 to 1 for sine, and from 0 to -1 here, for sine inverse and tangent inverse, I'm supposed to go from 0 degrees, or 0 radians, up to 90 degrees. And from 0 degrees down to -90, so negative angles. So will sine ever give me an obtuse angle? No. If I'm doing sine inverse, it's going to give me an angle between 0 and 90 or 0 and -90. Now, the law or cosine inverse, however, cosine starts at 1 and goes to 0 and then comes down to -1. So cosine, there's values down here that are also positive and negative for cosine, but we can only restrict it to 2 for us to have a function. Because for a function to be a function, if I give you an input of 30 degrees and ask you to find cosine, you can get only one value, and that's fine. But now if I ask you to do the reverse, well, it's not necessarily 30 degrees. It's 30 degrees and something else. So it wouldn't be a function unless we restricted it. So we have to restrict the domain so that we can only get values from here to here, so that we can only have one output for every input. So cosine, if you had used law of cosines, it would have given you an obtuse angle immediately if there was one, which is why law of cosines is a little bit more accurate. Law of sines is not as accurate when we're solving these types of problems. Now, here's the thing though. What is the largest angle supposed to be in this picture? Not necessarily the way I've drawn it. Which one? C, because it's across from the biggest side. So if I'm getting a number that's way off, they don't add to 180, that means that angle C must be obtuse, or else I did something wrong, but I know I didn't. It's obtuse, and what's happened is sine inverse gave me the reference angle. So we could go through and use law of cosines and see, oh yes, that it is actually an obtuse angle. But if it tells you the reference angle is 79 degrees, then what's the actual angle have to be? If the reference angle is 79 degrees, what's the actual angle have to be? 101. Because they have to add up to 180. So now, it's not going to be exact still, but it's going to be closer. I get 178. It's off by 2 degrees. Part of the reason is we rounded this. So our other two angles that we found might have been off slightly. But this is good for now. Okay? But at least we understand when there could be an obtuse angle. Because of that, if you're going to use law of cosines, what angle should you find first? The biggest, the smallest, or the middle? Because there's a chance that there could be an obtuse angle in our triangle, what angle should you find first? I'd find the biggest first. In this case, what's going to be the biggest angle? A. Because it's the bigger side. I know, right? Normally we make C the hypotenuse. It's not the case with these. They'll number them any random way they want. So find the largest angle first. Then, if you're going to use law of sines, then you can do the smallest, and then the middle. Okay? But always do the largest first with law of cosines. Then if you use law of sines, you don't have to worry about, did I miss the obtuse angle? So, and like in this picture, we intentionally went to find the biggest angle first. Here we want to find the, after we do law of cosines to find the side, we really should find that biggest angle first by using law of cosines before we use law of sines. So in this case, 18 squared equals 12 squared plus 14 squared minus 2 times 12 times 14 times cosine of angle A, which I don't know what angle A is. Again, because of order of operations, I'm able to square this. I'm able to square and add those, but I can't subtract them from this because this is all connected through multiplication. So I'm just going to do the 2, the 12, and the 14 and attach those to the cosine of A through multiplication. So 18 squared is 324. 12 squared and 14 squared give us 340. 212 and 14 gives us negative 336. Do not do 340 minus 336. This 336 is attached to cosine A through multiplication. So subtract 340. Giving us negative 16. Now we're going to divide by negative 336. You do not have to reduce it because it's not your final answer. On your quiz, some of you didn't reduce your final answer, which is a problem, especially being in pre-calc. But here I'm not worried about it because it's not my final answer. I'm going to do cosine inverse of 16 over 336 to get the measure of angle A to be 87 degrees. Now that I have the biggest angle at 87 degrees, I could find the smallest angle using law of sines and then the middle one, and they should add up to close to 180. So I will do that real quick. You could also, if you're like, no, I want to be very, very accurate, I don't want to have any room for rounding errors with the degrees, then you should use law of cosines to find all of these. In that case, I'd put angle B here, and the 12 would go here. The 14 and 18 would fill out the rest of this. If I were finding angle C, I'd put angle C here, the 14 here. The 18 and 12 would fill out the rest of this, and I'd repeat the process. Using just law of cosines, I'd get the most accurate answer possible. If I'm not as concerned about it being as accurate, I can do sine of 87 degrees that I just found over side A equals sine of B over 12, and sine of 87 degrees over 18, guys, it's picking up your entire conversation, equals sine of A over 8, no, side A is sorry, not A, sine of C, we're finding angle C, over 14. So now I can cross multiply and solve those to get angles B and C. Go ahead and work on that to see if you can get B and C correct using law of sines. Or if you want, you could try it with law of cosines. When doing law of sines to get this, I got 42 degrees for angle B. Using law of sines, doing sine inverse of 14 times sine of 87 over 18, I got 51 degrees. Those two added together with the 87 degrees do add to 180 degrees. So that works out nicely. If you're struggling with law of sines, or, which was the concept from the other day, this same lesson, but law of sines, or how to solve law for an angle with law of cosines, or for a side with law of cosines, please come see me. Otherwise, you guys are working on this practice for today, but this concludes this video.